Chapter 11, Section 6 is entitled Slope. Now we start with the definitions of slope. There are a lot of definitions for slope, and you will see this on the quiz tomorrow. It's a true-false section. I say to you, this is the definition. Is it right or wrong? So yes, you have to know these definitions for slope. All right, here we go. Definitions for slope. The steepness of a line. The ratio of the vertical change in a line to its horizontal change. M is how slope shows up in a formula. Y sub 2 minus Y sub 1. That indicates it's small like a power, but instead of being written up, it's written down. Over x sub 2 minus x sub 1. And that's how we find slope given 2 points. Triangle y over triangle x. Triangle stands for the Greek delta, and delta means change in. So when I say triangle y over triangle x, I mean the change in y over the change in x. And rise over run. Again, from the top. Slope is the steepness of a line the ratio of the vertical change in a line to its horizontal change. M, which is how slope shows up in a formula. Y sub 2 minus Y sub 1 over x sub 2 minus x sub 1 is how we find slope given 2 points. Delta y over delta x. Delta just simply means change in. And probably the most common definition of slope, rise over run. And our main focus today is just going to be talking about slope. Finding slope, positive slopes, negative slopes, zero slopes. That's the main focus of today. Okay, so let's go to example 1 where we start talking about slope. A train starting at sea level ascends a total elevation of 20 miles while it covers 50 miles of ground before its first stop. Find the slope of the distance covered. Train starting at sea level ascends a total elevation of 20 miles while it covers 50 miles of ground before its first stop. Find the slope of the distance covered. Okay, so one of the definitions of slope was rise over run. Now those two things are just what they sound like. Rise is how much something goes up, or it could be in this case actually down, a negative amount. Run is how much we go left or right on the graph. So as you can see from my terrible drawing here, right, the train, starting at sea level, has to come up 20 miles, and it's going to cover 50 miles of ground horizontally. So the slope is just the rise, 20, over the run, 50, and of course that can be reduced to 2/5. So the slope is 2/5. All right, now usually we're not finding the slope of just some drawing. Usually we're finding the slope of 2 points on a graph, which is what you see here in examples 2 and 3. Now when we find slope on a graph, we're always going to start with the leftmost point and work to the rightmost point, which is why I have it labeled on this one, a start and an end. Truth be told, you can actually start at either point, but it helps us from making some mistakes. If we do it the same way every time, our run is always going to be a positive number, which is one less problem, one less thing you can screw up. So the only thing then you have to worry about is the rise being positive or negative. Okay, so we're supposed to, in example 2, find the slope of the line depicted here. So, again, we always start at the leftmost point and work to the rightmost point. First thing I have to find is the rise. So how much I have to go up to get from here to here? Well, I have to go up 1, 2, 3, 4, or otherwise I'm making 4 jumps to get up to that point. And then I'm going to count how much I have to go this way to get to that point. That's 1, 2, 3 jumps. So my slope here is 4/3. How many jumps I had to make going up, and then how many jumps I had to make going to the right. All right, now 3A here is a little bit different, just a little bit. Again, we're always starting at the leftmost point and ending at the rightmost point. But as you can see, this line tips down. So when I count the jumps this time, it's actually going to be a negative amount to start with because I'm going down. I'm going down 1 jump, down a 2nd jump, down a 3rd jump, and down a 4th jump. So my rise is